Hey everybody, here with our third video in our five-part series on mediation. Here we'll be looking at some single variable examples using R. And when I say single variable, I mean single mediator examples to be more precise. There are a number of R packages that will perform mediation analysis. One that's not out right now, but is being distributed at various workshops is Process, which is written by Andrew Hayes. Andrew Hayes wrote similar pieces for SPSS and for SAS that are very widely used, and Hayes is widely considered, really probably the biggest name in the field of mediation, moderation, and conditional process analyses. He has a couple of books on that. So definitely when that process package comes out, that'll be probably the best source. There are a handful of other packages. One is called Process R, that's with the capital R. I don't like this one very much because it requires that we do a bunch of coding that basically is like writing our own, which we will end up doing, but we'll use a different package for that. Then there's also one called Process R, lowercase r. It's not on CRAN. It's available on GitHub. It just does a few models, but they are actually the most common models and probably the ones that is commonly used. If you want to explore that, you can use the remotes package to install that from GitHub. Mediation package provides a Bayesian approach. Lavon, which we saw when we talked about confirmatory factor analysis and structural equation modeling, is another very useful package. We're going to build our own model. A big advantage of Lavon is that it handles missing data really easily, which is why for most things I'm going to use that as the go-to package. And then there's also packages, MBES and Psych also have mediation functions. So there's a lot of ways to do this. We'll look at a few of these different packages, but we'll really rely on Lavon for the most complex stuff. The first example we'll look at is written using the Process R. That's Process R, the one with the lowercase r package. And you'll see the output that it gives you is labeled with the different pieces. So we'll take a look at those in a second. The command here in Process R is simply model 4, and that corresponds to models that are part of Andrew Hayes's book on mediation moderation. You can see we feed it the IV, the DV, the mediator, and the name of the data file. Pretty straightforward there. IV is X, DV is Y, mediator is M in the models that we've seen. The different paths that we get. The C path, the one at the bottom, let's look at that one. The C path is the total effect. That's the effect of quality to attitudes with nothing else in the model. We can see that that is statistically significant. Then moving to the A path, the path examining whether our predictor X is related to the mediator M. We can see that that's also significant. The B path, going from anxiety to attitudes, we see that that's also significant. And again, I'm just looking at those confidence intervals and asking if they exclude 0. C prime, that's noted as CP in many of the applications that we'll look at. We get an estimate. Don't worry about the fact that the standard error and the Z and the P value are not listed. The reason why that is that I'm sorry, I skipped on to the indirect effects. Let's go back to C prime first. Quality is still significant, even with anxiety still in the model. And again, we can see that 0 is excluded from the confidence interval. One thing to note here is that if we compare C and C prime, we can see that C prime is about half of what C is. So about half of the effect of C went away once we entered the mediator. Then looking down at the int, that's the indirect effect. That's the test of mediation. And we can see that we get a value of 0.228. Again, that's not really interpretable. That's not really interpretable anyway. Don't worry about the fact that it says standard error not applicable, Z not applicable, p-value not applicable. The reason why that is that This estimation approach uses bootstrapping, so it's not technically getting a standard error, and we're not calculating a z-value. We again do get a confidence interval. This is an empirical confidence interval, though. This is what range of bootstrap scores, from the 1,000 or so bootstrap samples that we took, what range of those scores, what range captured 95% of them with 2.5% cutoff either end. And we can see that goes from about 0.16 to about 0.31. Again, clearly excluding zero, so telling us we do have a significant indirect effect, or evidence for mediation if you prefer. These results actually correspond directly to the regression findings that we saw in the previous the regression results that we saw in the previous slides. The only place where they differ a little bit is in terms of the confidence interval for the indirect effect, and the reason why that is that as if these are bootstrapped, they're not calculated. All right, next up, there's a package called Mediation, which does pretty much the same, which does similar to what we saw. But what's interesting about Mediation is that it's calculating a Bayesian approach. We have to, in order to use this package, build our own models that include basically a model that predicts anxiety from quality, that predicts the dependent variable from the predictor. That's what I call MED2. And then predicts the mediator from the predictor variable. So that's I called it MED2. This corresponds to the second thing that we ran when we were doing the Barron and Kenny classic approach. So this is the model where we establish what the relationship between quality and anxiety is. And then we run a third, the next model that we run is labeled MED3. This was the final model that we ran when we did the Barron and Kenny approach. It's predicting attitudes from both the predictor and the mediator. And then we feed that into the mediation package. We just tell it the name of the two models. We tell it what the mediator's named and what the treatment is named. It calls this the treatment variable. We would call it more correctly the independent variable. And then we summarize it. It gives us some stuff that looks a good bit different. It gives us the ACME, that's the average causal mediation effect. That's basically an estimate of the A-B path. And if we compare that to what we got with other approaches, you can see that it's very similar. We get, our estimate is 2.23 here, where it was 0.228 previously. You can see the confidence intervals are also very similar. Gives us the ADE, which is the average direct effect. That's the C prime path. Total effect is the C path. And then it gives us the proportion mediated. This is roughly the ACM over the total effect. It's not calculated directly that way, not a really important value. And again, pretty consistent with previous things. A few things I don't like about this package. I think the output is a little bit minimal. I think that they are very casual with their use of the term causal. And the other piece is, and of course, one of the reasons why these differ a little bit is because they're using quasi-Bayesian confidence intervals. And I know I don't have to explain what those are to everybody. All right, next up is using, Lavaan. In Lavaan, and we've seen this before, we build different models that have a variety of different equations in them. And then we feed that to Lavaan, and it runs our analyses for us. In terms of how we're doing this in Lavaan, what we can do is we can predict, for example, for the direct effect, we're predicting attitude from quality. We start off predicting attitude from quality, and I've noted here CP. I'm actually labeling each of these effects. Attitude quality is going to be my direct effect. Now you might think, well, it's just attitude being predicted by quality. Within Lavon, as you can add predictors as we go. So when it sees attitude also predicted by anxiety, that means it's actually going to be predicting attitude from both quality and anxiety in the same model, and that's why this would be the direct effect. I have below the stuff dealing with the mediator. We're going to have to predict the mediator anxiety from quality, and I've labeled that with an A. So what that is going to do is it's going to take that path and it's going to save it for us, and it's going to give us some output related to the A path. I did that with the B path, attitude predicted by anxiety. And then the indirect effect is just calculated using this this format, AB colon equals A times B, and that's going to create the indirect effect. And then the total effect, I'm sorry, the direct effect, I'm sorry, this is labeled the direct effect, but it should be labeled the total effect. Oops. All right, and through the magic of technology, it is now labeled as the total effect. The total effect is defined as C prime plus AB. So we can see that that's getting us the whole thing. Other ways to get the total effect, but mathematically they're all equivalent. The SEM command runs the model, and we'd have to tell it the data, and then adding SE equals bootstrap means that it's going to calculate bootstrapped effects for our indirect effect and all of the other effects. Again, this doesn't really differ from the Barbarian and Kenny approach. The only way it does differ is that it's a little more minimal. We're not having to run 3 different analyses because we can get all the information that we want from a couple of different pieces. Here's what the Lavon output looks like. You're going to see, and I've laid one thing with it, which is how Lavon labels these pieces, which is something I really like. The direct path quality predicting attitudes has an estimate of 0.245, around what we saw for C prime in previous examples. Quality predicting anxiety, the A path about negative 0.51, and then anxiety predicting attitude, the B path, negative 0.45-ish. You can see that those are all significant. The piece here with the variances, don't need to worry about that. And then defined parameters, that's where we're going to get the indirect effect. It also gives us the total effect. So the indirect effect gives us an estimate of about 0.23, and we can see it gives us a standard error or z-value, but I'm just going to use the confidence interval. Confidence interval here ranges from about 0.15 to about 0.31. Comparing that to what we did with the regression approach earlier, where we got same estimate for the effect, slightly different confidence interval. Again, really consistent across different procedures. You will find somewhat different results, and that's fine because bootstraps are going to produce different results. In general, the feeling in the field is that you really should be using bootstrapped estimates at this stage. All right, another package here is MBES. MBES is really a package that's mostly about effect sizes, but it does provide some effect size estimates for indirect effects. Although in this part of the MBES package, I think most of the effects that are estimated have been shown to be limited in one way or another. The package authors encourage use of a different type of package called different command if you wanted a mediation effect size, but really hardly anybody deals with mediation effect sizes, so we won't go into it. With MBES, you simply are feeding it the name of the different variables. You tell it to bootstrap, and then under which boot I put both because it has 2 different estimation techniques, and then that value B is how many bootstrap samples it's going to take. As a warning, most of these bootstrap approaches are going to take some time because when you have to draw 10,000 samples, depending upon the kind of computer you're using, it could take a minute or 2. The output down below, this is a really limited, I've really limited the amount of stuff in the output here. Just to keep it a little bit more manageable. It's probably a good page of stuff. It gives us an indirect effect, and then the next 2 numbers, lower CI lower percentile, CI upper percentile. That's the lower limit and the upper limit of our confidence interval using what's called the percentile bootstrap. And then the second two numbers, so the fourth and the fifth numbers there, 0.1596, 0.3073. Those are using a different bootstrap approach, which is called the bias-corrected bootstrap. Somewhat ironically, the bias-corrected bootstrap approach is biased and it's not recommended for use. So they probably need to rename it. All right, so just to summarize, doing analyses with R. One, there's a lot of different ways to conduct mediation analyses. I wanted to highlight some of the features of some of the better packages. All are going to yield relatively consistent results under most conditions. I would say if the package you choose is going to make a difference in whether your result is significant or not, then you probably don't have evidence, decent evidence for your hypotheses anyway. Many of the packages are limited. Most of them cannot handle multiple mediators or even multiple predictors. For that reason, my primary recommendation is going to be using Lavon throughout for all of our purposes. All right, the next set of slides will cover exactly that, using multiple mediators, and we'll take a little bit of a deeper dive into Lavon.